In this video lecture, I'm going to teach you the 5 controls on temperature. And they're quite simple. They are these objects or these types of locations have an influence on temperature. The first one is latitude. Latitude has an influence on temperature. If we start at 0 degrees north and south, which is the equator, and we go north to 30, and then to 60, and then finally to 90, it gets progressively colder. And that coldness, it gets cooler as we go from 0, the tropics, to the 30 degrees north to 60 degrees north, and then finally we get to extreme cold at 90 degrees north. So these temperatures change according to latitude. So this is a temperature change by latitude. The next control on temperature is altitude. Altitude is the change in height. So if we have here, we have a valley, and then we have mountains. If we have a person that stands here with a thermometer, and then we have a person that stands here with a thermometer, and I place the sun here, let's consider, what is the temperature going to be, the relative temperature for the valley? Is it going to be warmer or cooler than the mountaintop? Well, the answer would be that this is going to be warmer. This valley will be warmer than this. And the reason is, even though the person here staying with the thermometer is closer to the sun, look at the amount of space that you have from here to here. There's a great deal of surface area. And this surface area is absorbing all of the solar radiation. Therefore, it's going to continue to be warmer than this location, which has a very small surface area. So mountaintops have a small surface area. Therefore, and if you really think about it, you remember these? We have ice caps on the tops of mountains. We are further away from the massive landscape at the bottom of the mountain. So this is kind of a very small point, topographically speaking, compared to this. So the closer that you are to the sea level, you will get a warmer temperature. And as you go up in altitude, that temperature decreases because you're getting away from that vast landscape that is doing all the absorbing of the solar radiation. The next control on temperature is continental versus marine environments. It's continental versus marine environments. If you have a location that is, well, let's just take it in. If you have a location that is in the middle of the continental area, let's say here is Fargo, and then several thousand miles, you have the ocean, and you have a city that's here in the ocean, near the ocean. Which one is going to be the most extreme environment? Is it going to be Fargo, or is it going to be Boston? Well, let's consider this. When we have moisture, the temperature drops slightly. When there's moisture available, then the temperature comes down a little bit. If there is no moisture, then the temperature wants to go higher. So if we consider Fargo, there is no vast body of water out here. And so you might get a 95-degree temperature that is the maximum for the year. And then during the winter, you get a negative 20-degree difference, which is the minimum in winter. So this is a great change in a variation in temperature. On the other hand, you have Boston. It might be, let's go with 90 degrees is the maximum for the year. And then perhaps we get a 65 as the low. Well, that's optimistic enough. So let's say we'll get about 20 minimum. All right, these are just hypothetical numbers. I'm just throwing these numbers to show you the differences. And so here you get a great extreme in temperature. Here you get a less extreme in temperature. The reason why this is less is because it is located near water. This has an extreme environment, an extreme temperature change, variation, because it is experiencing continentality. Continentality. When you have, like St. Louis is in the middle of the continent. Fargo is in the middle of the continent. Denver is in the middle of the continent. So you get this continentality effect when there is absolutely no water. No water, I mean significant bodies of water to control the temperature. So that's why it gets very hot in summer and gets very cold in winter. On the other hand, other environments that are along the coast have less extreme temperature change or less variation because they are near bodies of water. Now let me explain how this all works with we'll take two environments. We'll take our neck of the woods. You have an urban environment which is made of asphalt, concrete, glass, metal, and those kinds of objects. There's very little green space. So you get a high temperature in the city. On the other hand, you get an area outside the city, the rural area, which is got trees and it's got plenty of grass. Sometimes you've got crops, you've got corn growing and beans and various other crops that are growing. So you have vast amounts of green space. The temperature in the country might be, compared to the city, lower. The reason why you have differences in these two environments that are relatively close to each other, you have latent heat. Latent heat is low because there's no water stored in the soil, because there's no exposed soil. And I'll get to the definition of latent heat momentarily. In the country, the latent heat is very high because in the soil you have enough moisture stored. It's exposed. The soil is exposed. It stores the moisture a little better. So you have moisture storage, moisture that is stored in the soil, and you have no moisture in this environment. So the temperature goes up. And I'll explain it in a different way how this all works too. Latent heat. Latent heat is the stored heat energy. It is heat that is stored. It is hidden. The reason why it's hidden is because there's moisture somewhere for evaporation to work. And so instead of releasing heat, it is pulling in the heat. Therefore, you get a lower temperature. If you consider sweat on your skin, if you have sweat on your skin and a breeze blows across it, how do you feel? You feel cooler because there's latent heat going on. There's evaporation. The heat is being stored in order to evaporate. All right, now another way to explain this is the process of how heat is emitted. Does heat emit if latent heat is high? Now let's have a look at an airplane that flies over the urban center and then flies over the country. Put a tree in there. All right, we have an airplane that flies over both environments. Now, as we said before, the temperature is high over the urban environment because latent heat, LE, the abbreviation of latent heat, is low. On the other side of this, temperature over the rural region is low because latent heat is high. So what do we expect? Where will there be turbulence? turbulence will be experienced over the urban area and smooth out over rural areas. The reason why, if you have no surface moisture, latent heat is not going to function. Therefore, you've got more heat emitting from that city. On the other hand, when you do have soil moisture, you have moisture in the soil, the temperature is controlled by that latent heat. So now you don't have very much heat emitting from the surface. So the flight, the airplane, the flight will be extremely smooth. So that is continental versus marine. We're looking at two environments. One, the continentality effect, where you have a city that's in the middle of a continent, or you have a city environment where there's not much moisture stored at the surface. And then you have the coastal regions or coastal cities, and you also have the urban or the rural regions where there's a lot of moisture around to control that temperature. Another control on temperature, the fourth control on temperature, is ocean currents. Ocean currents help to moderate temperatures to the extreme north and at the equator. So for example, we have, if we consider, here is the equator, here is the polar region, the tropics are here. We'll say that this is the USA, and then over on this side, we have Europe. Now this is a very basic, simple diagram. We have a warm current that moves from the tropics close to the eastern seaboard of the United States and moves to the north. This current is called the Gulf Stream. It takes warm water from the tropics and moves in this current to the north to moderate temperatures in the polar region. Therefore, you do not get a very cold environment in the polar regions. It's still cold, but not as cold. On the other hand, so the tropics do not get too hot. We have a cold current that moves from the north to the south. So on the eastern side of the basin, the oceanic basin, we have cold currents that move from the north to the south to help bring down those tropical temperatures. So now we've got this moderation, warm, cold in the northern hemisphere. The same situation occurs in the southern hemisphere. So we're moderating temperatures. If this were to shut off, then what would happen? The tropics get very warm and the polar regions get very cold, and we see more ice form in the polar regions. And this phenomena is what has happened in the past with climate change 5,000 years ago and 15,000 years ago to 18,000 years ago. And there's a possibility of what we could see in the future with continued climate change. But we'll cover that at another time. The final control on temperature is cloud cover. Cloud cover controls temperature at the surface. So if you have a clear day, contrary to what you might think, if you have a clear day, you have insulation, you have heat that escapes. Clear day, it has to be extremely clear. The relative temperature without any clouds is going to be cool because the heat is escaping in the atmosphere. If you bring in the clouds, you also have cool in conditions. No sun has been seen all day, so there is no absorbing at the surface, so you get a cool day because no insulation has reached the surface of the earth to be absorbed, to increase that heat. Now, if we consider changing this a little bit to make it warmer, what we get is this. We get insolation. There's absorption going on in the AM. Then in the afternoon, we get clouds moving in. We get clouds moving in. But what happens is that radiation is being stored at the surface. It is emitting back and forth between the cloud and the ground. So the cloud is acting like a blanket. During the morning, you have accumulation of radiation at the surface. It is emitting heat. It continues to absorb solar radiation, but then the clouds move in the afternoon. Then you increase that temperature because now the clouds are acting as a blanket. So those are the basics of the 5 controls on temperature. To recap, we had first the latitude control on temperature, which is the decooling of temperatures to the poles from the tropics. We have altitude. Altitude, where the lower elevations will have greater temperature, more heat than higher elevations, even though you might be closer to the sun. Then you have continentality. Continental versus marine. This has everything to do with the bodies of water, where your location is in regards to bodies of water or no bodies of water. Then we had the ocean currents. Where you moderate the temperature from tropics to the poles and vice versa. You have transfer of heat and transfer of cold temperatures via the ocean currents from poles to the tropics and vice versa. And then finally we had cloud cover. Whether clouds come in acting like a blanket, keeping things warm at the surface, or no cloud cover, which allows radiation to escape into space.